Hello, let's continue our Sudoku adventure with Double Duty by Strosahl. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now we have another duality constraint. So I'm going to talk about them separately, but each of these has to fulfill both of the constraints. But these are standard constraints, so I'm going to talk about them separately. So first, they have to be little killers, which means if we look at the arrow and the cells it points at all the way to the other end of the grid, so these two, for example, this 9 is what they add to. So for example, this could be 4, 5. So 4 plus 5 is 9. They would add to that 9. And you'll note that we just have these small sums here. So these two add to 8, these two add to 6, these two add to 9. In addition to that, the clues outside the grid act as x sums. So we ignore the arrow for the x sum. We just look at the row or column that it's marking. And you take the first digit right next to it. So say this was a 3, then we would say that these 3 digits add to 9. So maybe something like this, 3, 1, 5. 3 plus 1 plus 5 adds to 9. That fulfills this x sum. If this was a 2, we would have to have these 2 add to 9. If this was a 4, we'd have to have these 4 add to 9. And again, they are both. You don't get to choose. They have to fulfill both of those constraints. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, well, 6 is only 1, 5, or 2, 4. The other ones are pretty open. Well, no, 9 is only 4, 5, or 3, 6. 8 is a bit more open. It's just not 4. But we should probably think about the x sums. So an x sum of 6, we certainly can't be a 1 here. That would sum to 1. If we were a 2, we'd be 2, 4. And if we were a 3, we'd be 3, 2, 1. With a 1, 2 pair here. So this is what these two are limited to. A 4, there is no way to add to 6 in 4 cells. Minimum is 10. So this is 2 or 3, and this is 1, 2, or 4. If this was a 2, this is a 4. If this is a 3, this is 1 or 2. For the 8, we could do 2, 6. We could also do 3. These two would add, with the 3, these two would add to 5. So they'd be 1, 4, 2, 3. Well, they couldn't be, with the 3, they couldn't be 2, 3. So they'd be 1, 4. So 1, 4 only. And then you can't get to 8 and 4. And this 9 is also, well, it can't be 2 because 2, 6 only adds to 8. So it could be 3 and 4 adds to 10. So this is a 3. And that makes this a 4, 5 pair. I did the best one last. Oh, well. Does that affect this 8 at all? Like, how are we adding to 8? Actually, how are we adding to 8? 2, 6, or 3, 5. That's it. That's it. That's all we get. 3's in one of these two. 4 is in one of these two. What's this 4 doing here? Is there a problem with 3, 1, 4 here? Yeah, okay, so these can't both be 3. Because if they were both 3, then by roping, we know these 3 digits are the same as these 3 digits. Just like, where do they go in this box, right? These 3 are the same as these 3. So if this was a 3 and this was a 3, we'd be using the same 3 digits to add to 6 and 8. So this is a 2, 3 pair, or both are 2. Something to keep in mind. So if this was 3, 1, 4, the problem is that there is no 2 available to use for the 6, right? If we used a 3 here, this cannot be a 3. It would have to be a 2, but 2 wouldn't be available if I did 3, 1, 4. So therefore, this is not a 3. This is a 2, and then this is a 6. So that can't be 2, that can't be 6. So if that's not, yeah, that, I guess that's what happens. And so we need a 6, and that's going to go here, which means that this is 2, 4. Okay, and that's not 2, that's not 4. So that's a 4, and then that's a 4. We get the 5 and 4 here. That can't be 5, that can't be 4. So we should be able to finish this. Yeah, it's 1, 5, like that. All right. This can't be 5, so that can't be 3. Now this is 1, 3, 5. And this is 1, 3, 5. What am I missing? So the 8, the 9. Oh, the 9 is in 3, right? We should think about this then. So these two add to 6. So they're either 1, 5 or 2, 4. Well, this can't be 2 or 4. So it's going to be a 1, 5 pair. This 5 tells us that's 1, that's 5. This is a 2, 6 pair. The 6 tells us that's 2 and 6. So over here we need 2 and 4. Wait, that's 4, that's 2. Oh, this is resolved. 5 plus 3. That's 1 and 3. These two digits are the 3 and the 6. That's 3, that's 6. This digit's a 1. These two digits are 2 and 6. All right, so up here I need 1 and 3 and either the 2 or 6. Well, this isn't the 2 or the 6. So this has to be the 1, 3, and this 1 tells us the order. That's 3, that's 1. That's 5, 3, and 1. So this is... Oh, sorry, I said it's not the 2 or the 6. Wait a minute. I did that backwards. This 2, 6 can't go here. In fact, why don't we just place... I don't know. This is 2, 3, 5. Anyway, I just like this. This 2, 6 can't go here. Therefore, it goes over here, squeezing the 1, either the 1 or the 3 here, but the 3 tells us it's the 1. And that resolves it. Whoops. This can't be 3 or 6. This has to be the 2. Which makes that 6 and 2. Which makes that... what a weird way to end it. That makes this 5 and 6. All right. Just having some fun. Probably could have just penciled and done naked singles, right? Alrighty. Well, that was fun, Strosahl. I enjoyed that. Not a whole lot of interaction between the duality, but it's an interesting set. Like, it's interesting that this was possible with 3 clues and the given 4. So I enjoyed it. How'd you do?